everyone. My name is Stephanie.
I'm Chandler.
And we are some of your outreach officers for the Society of Physics Students here at the University of Utah chapter. Today, we're going to be filming one of our very first demo videos, which is meant to be used as outreach material. And what we're going to be focusing on today is going to be electricity and magnetism. We're going to be demonstrating the properties of electricity and magnetism with this machine here, which is called the Graaff Generator. So just a little bit of background on what this whole thing is. So the Graaff Generator was first invented in 1931 by Robert Van de Graaff. And some of the cool things about it is when it was first invented, it was actually supposed to be a particle accelerator. So I guess we could still technically use it as that, but it's a lot cooler to use it as a demonstration to get people excited about physics. So some of the things that we're going to do to show these electricity and magnetism and some of the principles about that are going to be using some yarn to demonstrate how the electrostatic potential builds up in this sphere through the cranking of this wheel right here. And another experiment that we're going to use is by blowing bubbles at it. So that's going to be fun, and we're going to see how the bubbles interact with the sphere when it's completely off like it is right now, and also how they interact when we start cranking the wheel and creating some electrostatic potential around the sphere itself. All right, so now that we have that out of the way, let's go ahead and start our experiments, and we'll go ahead and get started with the yarn.
Yep.
Right?
Okay, so let's just talk about this a little bit more detail so you can understand what's going on here. So the Van de Graaff generator has a little metal cone here on the outside, and it's negatively charged. And on the inside, we have a positively charged roller. And in between the two is a rubber belt, which is what this is. And as I turn it, that belt moves. And so what's happening is the negative charges are coming from this positively charged cone, jumping to the roller, but being intercepted by the belt. And then as I turn this, I'm bringing all those negative charges up to this big metal sphere here. And as I do that, we're building up more and more negatively charges on the top of the sphere. And so what happens is, with the yarn here, you can see it's starting to repel each other. What's happening is the electrons are building up on the yarn and repelling itself. And so it stands up. And you can also see as I grab this, which is the ground, the yarn falls back down. So what happened is the charge became so strong on the metal sphere that it could actually ionize the air and jump to this ground here. And all of those charges are now gone.
You said that was similar to lightning, right?
Yeah, similar to lightning.
Yeah, so that's super cool.
Cool.
All right.
Bubbles.
Let's go with the bubbles now. All right, so like Chandler said, with the electrostatic potential building up on the sphere, if it becomes very large, it ionizes the air around it. So we're gonna see, actually, do you wanna ground it first? And then we'll see how the bubbles interact without the crank going. Let's see if I can blow proper bubbles this time. Okay. All right, so let's check it out and see what happens. Okay. Just kidding. Let's do it one more time. That was just a fake. All right. So only like one or two bubbles ended up going onto the sphere of the generator.
Yeah, they kind of just float around as if the generator's not even there.
Yeah. So let's go ahead and start cranking it and see what happens to the bubbles, or how they interact with the generator as it's building up potential. Okay. Cross my fingers, I can blow this right. Okay. All right, not sure if you guys caught that, but I'll do it one more time. You could see some of the bubbles were attracted to the sphere. Instead of just floating by aimlessly or just floating in the air, it seemed like they were getting attracted to the metal sphere. So let's show that one more time, when I can actually blow a proper bubble. Oh, only one of them. Okay, third time's the charm. Maybe I need to take bubble blowing lessons too. Oh, so that one looked like it was repelled, didn't it?
I think it was the same thing. The bubble popped and pushed it away. The other bubble.
Yeah, that's what I was gonna say. But it looked like it got repelled. But yeah, so that was just the air from the bubble popping that pushed the other one away. This is, all right, here we go.
That was much better.
Yeah, that was really cool. All right, so I know it's a little hard to see, but we could definitely see that the bubbles interacting with the sphere. Put this back on. The bubbles interacting with the sphere of the Van de Graaff generator were attracted more to it when the air around it was ionized due to the electrostatic potential, as compared to when we blew the bubbles when everything was just grounded. They would just flow by and not really notice that the Van de Graaff generator was there. So yeah, all right. I hope you guys had some fun watching this video. If you guys liked this demonstration video, check out the rest of them that we will be making. We'll be doing something with thermodynamics as well as with angular momentum in the future. Thanks for watching.